Welcome back, everybody. This lesson, we are going to talk about the present value in compound interest. So to date, we've been working with the compound interest formula. F equals P 1 plus I over M to the MT. And in the previous videos, we have simply been solving for future value. And future value has taken on other terms in the examples that we've been doing, and most commonly it has been called maturity value. We're going to extend our working with this formula and now look for this variable p. And in further lessons, we'll be looking at the other two variables, I and t, but for this lesson, we're going to focus on solving for p. Now, p, as we've seen, is the present value, or the initial value, or the start amount, or the loan amount. When we find present value, what we are doing is we are taking the interest off. All right, so we are not using any formula that's new. Instead, we're going to use the same formula. There's only one formula for the present or for the compound interest questions that we are doing in this course. All right, so let's take a look at how we can use this formula for present value. Now, currently, this is the formula that we've been using for future value. Now, if I take this equation and divide both sides of the equation by the 1 plus I over m to the mt, so I'm going to divide both sides by 1 plus I over m to the mt. It cancels out of this side and just leaves me with p. Now, this version of the formula, many folks use this p equals f divided by bracket 1 plus I over m to the mt. However, we're going to be doing some more rigorous algebra, and there's a second version that is very helpful that I like to use, and it's p equals f 1 plus I over m to the negative mt. And if you think back to your high school math classes, when you did exponent laws, recall that if you have an exponent in the denominator, so this is down in the denominator, it's equivalent to having that exponent in the numerator and making it be negative. So this is the version of the formula that we will be using when I solve the problems. And as I've said before, we won't be using any technology. We'll address technology in Math 53. And for now, we'll just focus on using the formula to solve for everything that we need. All right, let's look at our first example. So it says, use the formula to determine the present value of an investment with a maturity value of $8,650.25 at 4.2% compounded quarterly after 3 years. All right, so we see that we're dealing with a compound interest application, and that we want to find the present value. So we can take this rearranged version of our formula, which is P equals F 1 plus I over m to the negative mt, and we can substitute in all of the numeric values that we know from the question and solve for what is missing. All right, so in this case, F is equal to the maturity value. It is $8,650.25. Our interest rate is 4.2%, so I is equal to 0.042. And we're compounding quarterly, so that means that m is 4. And our time is already in a unit of years, so t is 3. So now let's replace everything in the formula. We have F 8650.25, 1 plus 0.042 over 4 to the negative 4 times 3. All right, and perhaps I'll take a moment and simplify this down. So this is 1.0105 to the negative 12, and then we can get our final answer to 2 decimal places. And our final answer is $7,631.20. Now, you should always do a double check when you solve for present value. And you should double check that you have gotten a value that is lower than your future value, because present value is always smaller than future value. We've taken the interest off. All right, let's try another one. It says find the present value of $7,344.55 due in 38 months at 6.4% compounded quarterly. All right, so again, I see that I am looking for present value and that I am dealing with the compound interest formula because I see that keyword compounded. All right, so we know that we have a future value that is $7,344.55. We have a time of 38 months, and we know that that has to be converted to years, so it's going to be 38 over 12. I is equal to 0.064, or 6.4%, and M is compounded quarterly, so M is 4. All right, so let's take our compound interest formula that is isolated for P. And substitute in everything that we know. We know that our future value is $7,344.55. We know that I is 0.064. M is equal to 4. And we have a negative 4 times 38 over 12. And just a little reminder, do not forget that with the present value formula, that symbol up in the exponent is negative. All right, let's simplify this down a little bit. 7344.55. This is 1.016. And our exponent is negative 38 over 3. And you can just use your fraction key to simplify down that exponent. And then finally, we can punch this now into our calculator and get our final answer. Of $6,006.82. All right, let's do one more together for this particular lesson. And let's look at a harder one where we actually have to count time. So it says determine the principal that will accumulate to $12,978.38 from October 15th to May 17th or May 15th, 2024 at 4.8% compounded weekly. All right, so we're looking for principal, and principal is yet another way to say we want the present value. And we know from our variables that our future value is $12,978.38. We know that our interest rate is 0.048. We're compounding weekly, and we know that there are 52 weeks in a year, so M is equal to 52. And we have to do a calculation and find time. All right, so timelines can be tedious. They take a little while to draw out, but they are all very helpful. And I would encourage the more you can do with a timeline, the better to get used to, particularly for when you get into Math 53, it'll set you up nicely. So we're going to count from October 15th of 2017, and we're going to count full months or full years of October 15th, until we get close to that May 15th, 2024. And we know that October comes after May, so we're going to need to stop on 2023, the year before, and then count to our May destination. All right, so we have, we're going to count by years here. So this is October 2018 and October 2019, October 2020, October 2021, October 2022, and October 15th, 2023. So we know that we have a total of 1, 2, 3, 4, 5, 6 complete years. And now we're going to count up to our May 15th destination. So October, then we have November, December, January, February, March, April, and May. And again, we're going to count those spaces to figure out how many months. We have 1, 2, 3, 4, 5, 6, 7 months. So our T is going to be 6 years and 7 months. Now we have everything that we need for our formula. We can substitute in our present value formula. Our future value is $12,978.38. Our interest rate is 0.048 over our M of 52. And our negative exponent is 52 times 6 and 7/12. Now, my fine folks, this is not one of those situations where we actually want to simplify down what is in the bracket. We don't want to do that because it's not a nice decimal when we divide 0.048 divided by 52. So I will simplify down the exponent, but I'm going to leave this as is, and we're going to just punch it in so we keep as much accuracy as possible. So let's simplify down that fractional exponent. And I get negative 1,027 over 3. And now let's punch this in our calculator. and get our final answer. All right, so I get a final answer of $9,463.39. Now, if you found that difficult to punch in your calculator, just below here, I would like to take you through the keystrokes that I entered into my calculator. So here are the keystrokes for getting that into my calculator. So I find it helpful if I do order of operations for my calculator. So I find it helpful if I take care of this part of the formula first. So I went 0.048 divided by 2, and then I pressed equals, and plus 1, and I pressed equals, and then I did to the exponent bracket negative 1027 divided by 3. Very important that that's in brackets, and I pressed equals, and then I did times 12,978 and 38 cents. And if you follow, if you have one of the calculators that is not one of the high functioning calculators, these keystrokes will be most useful for punching in something a little bit more complicated as above. All right, that's all the examples that I'm going to do for present value. You are welcome to complete example 4, 5, and 6. The answers are online in the student practice. I do want to bring your attention to your student practice, and I want to point out that you're going to run into some questions in the practice that are having you count time, and they are, like January 12th to March 24th in this part C, and I've said to you that we are not counting anything that is not going from January 12th to March 12th, an estimation, and that if you run into these in the student practice, that you should just use the number of days that are provided in the solution. So when you go to compute this, your time is going to be 2628 over 365. All right? Otherwise, the student practice is very doable for you at this point with what we just finished in the note. All right, take care, my fine folks, and I'll see you in the next video.